Hi everyone, thank you for joining us today. My name is Anna and I will be hosting. We're just going to give it another minute just to wait for a couple of people that are still joining, and then we'll start. Okay, hi everyone again. As I said, my name is Anna Nye and I'll be hosting. Today our webinar is presented by Francis Craster, who will take us through the fundamentals of motor starting and selecting the right tool. At the end of the presentation, we'll have some time for questions. Before I hand over to Francis, just a few housekeeping. On your screen, you will see to the left the GoToWebinar viewer, where you will see the presentation. And to the right is the control panel, where you can ask questions and select audio mode. Throughout this presentation, everyone will be muted by design. You're able to type any questions along the way in the questions box in the control panel. At the end of the presentation, we will run through the questions raised. If we run out of time, the questions will be answered offline afterwards. There will be a survey after this webinar, so we ask please to take a minute to give us your feedback. The webinar will be recorded and available after. And with that, I'll hand over to Francis.
Thanks, Anna. I'll just start my camera. Hi, everyone. I'm Francis Crasta, and I'm the Product Marketing Manager for Motor Protection and Safety. I'm sure you all know motors are all around us, and every electrical engineer or an electrician must have come across it either with respect to its wiring or a selection of the components. Today, I will help you understand the fundamentals of motor starting and selecting the right components. I will kick off this presentation by a quick poll. How many motors are installed around the world? Okay, so the poll will be in front of you. There's only one answer is correct. I will give you 30 seconds. Okay, so hopefully you guys have completed the poll. Okay, the results are on your screen as well. So why is it so important that we are talking about motor starting? The answer to your my first poll is there are around 400,000 electrical motors installed worldwide. This is the number which was given to me by the factory last year. I'm sure that it must have increased. You'll be surprised that 90% of the motors run on full speed, that is DOL or star, star delta, or soft starting, and only 10% on variable speed. So these are some of the starting methods which we use. We use direct online starting. This is a common and simplest way of starting in our industry. We use star delta starting as well. It depends. In some countries, it is a rule that anything above certain kilowatt, you need to start a motor with star delta, especially because there's a high interest in DOL. So they usually basically start in star delta starting. Auto transformer starting, slip ring motor starter. These two type of starting methods, I have to be frank, I have not come across this quite often, but we still have we have a selection guide in our manual. Variable frequency drive and soft starter, we come across this as well quite often. So what is the difference between a contactor, soft starter, and a variable frequency drive? A contactor can turn on and off a motor, and the motor runs at basically full speed. Soft starter can soft start a motor, the motor runs at full speed, and you can soft stop it as well. Whereas in variable frequency drive, speed can be controlled throughout its entire operating cycle. So on your screen, you can see a supply and a motor. And what functions or what protection do you require for a motor? So you require to isolate and disconnect the line safely. You require protection against short circuit. You require to switch on and off the motor, protect against overload, protect against phase failure, control the speed of the motor. And what components do you require to get all this protection? You require a fuse or a switch disconnector, switch fuse, a breaker, manual motor starter. You require a contactor for sure, a soft starter or a drive, overload relay, electronic compact starter, and the list goes on. Uh, Basically, you will require these basic products or components in your control panel. Now, again, I'll go with a quick poll. Which statement you think is correct? The poll is in front of you. I'll give you 30 seconds again, and yeah, just go for it. So I have something similar, two more polls for you guys. So better you need to concentrate on what I'm presenting. Okay. So the poll results are were on your screen. Anyways, so on the top you can see all the products or all the components, and on the left you have the protections what those products do. So fuse can protect against short circuit and isolate the line. Switch fuse can do the same. Breakers can protect the motor from short circuit, can isolate the line as well. It also can protect against overload. We have a special version in our XT and T-Max range with eKeep M the protection. You can also have a protection against phase failure. With manual motor starter, you can do quite a lot of things. Short circuit protection, isolate the line, start and stop the motor, protect against overload, protect against phase failure as well. So this was one of the questions in the poll. Contactor can only start and stop the motor. It cannot isolate the line. Overload relay, protect against overload, and also against phase failure. Electronic versions can give you that protection. When it comes to soft starter, it can start and stop. It can protect against overload, and of course, it can give a soft start as well. Variable frequency drive, it can start and stop a motor, protect against overload, protect against phase failure. Yes, it has a phase failure protection as well. Soft start and speed control as well. Electronic compact starter, which is one of the most compact starters in the world. It can isolate the line for maintenance, start and stop a motor, protect against overload, and protect against phase failure as well. And you require all these components. So these are the components what I just showed in my last slide. And how do you like the arrangement? So you can use only manual motor starter to start your motor. You can use it with the contactor to if you need to use it with the push button. You can use it with a switch fuse and with the overload, because overload cannot give you short circuit protection. So you need to have a switch fuse as well for short circuit protection. Here we are using magnetic only a manual motor starter with an overload. So magnetic only will give you short circuit protection. Magnetic only manual motor starter with an electronic compact starter, because electronic compact starter can give you overload protection. We have this compact solution as well, with mini contactors and an overload, and magnetic only manual motor starter. And finally, anything above 100 amperes, we can go for MCCBs with special trip unit, eKeep M, and with the contactor. Now, what is the difference between a circuit breaker and manual motor starter? Both are circuit breakers, but they have a particular task to do. So a circuit breaker can be used for power distribution, line protection. It can be used for one line or several branches downstream, whereas manual motor starter can be used for only one line downstream. Circuit breaker can be used for motor protection as well. As I've just mentioned, we have special trip units in our MCCBs. Manual motor starters can be used for motor control as well as protection. They are specially designed for that. We have a setting knob, and we need to set the current of the motor. They are in higher ratings, anything above 100 amperes, and they go up till 500 or 600 amperes. Whereas manual motor starter can go only up till 100 amperes. Circuit breakers are of larger footprint, whereas manual motor starter are very compact. So we have products from motor control to power distribution, as you can see in the slide. We have contactors AC3 and AC1 category. Like one contactor can do both AC1, AC3, and there are many more categories as well, which I will go in my future slides. So in AC3 category, we have contactors from 9 amperes to 1050 amperes, and AC1 category 22 amperes up to 2850 ampere. This is one of the biggest contactor around the world in block type. For short circuit protection, we have breakers from 1 ampere to 6300 amperes, and motor protection manual motor starter is from 0.1 amperes to 100 amperes. We have overloads, thermal and electronic. Thermal goes from 0.1 to 200 amperes, whereas electronic can go from 0.1 to 1250 amperes. We have mini contactors as well. It can go up till 11.5 amperes in AC3, and electronic compact starter AC53A, that is for motor protection. It can go up to 6.5 amperes. Now I would like to go with some definitions of a contactor. A contactor is a mechanical switching device having only one position of rest, operated otherwise by hand, capable of making, carrying, and breaking currents under normal circuit conditions, including operating overload conditions. So anything can be a contactor. Even a switch in our house can be a contactor, because it operates basically manually, can carry, break, or make currents. Whereas we have the contactor, which you can see on the left, is an electromagnetic contactor, and the definition is it is a contactor in which the force for closing the normally open main contacts or opening the normally closed main contacts is provided by electromagnetic. So as you know, the contactor which you see on your screen, basically you actually apply the supply, and the magnet pulls in the main contacts. So these are the categories which are very important when it comes to selecting the right contactor. So whenever someone tells you that I need a contactor for 9 amperes, you need to make sure, you need to ask the duty of it, or a category. So AC1 category in alternating current, it is for resistive loads or slightly inductive loads. AC2 is slip ring motors starting and switching off. AC3 is used for motors more often, and we have a selection chart for AC1 and AC3 in our catalog. AC4 is for plugging and inching. This for a high type of hard starting. And we have many more, but we'll concentrate on AC1, AC3, and AC4. And we also have AC6B, which is for capacitor bank switching. So in capacitor banks, there is high inrush. The inrush can be 100 times or more than that, the rated current. So we have special contactors, especially for capacitor bank switching. And then we have direct current as well. DC1 is for resistive loads. Again, it is something, it goes on something similar to alternating current. So again, a quick poll: what statement you think is right? 30 seconds again, quick one. Okay, so here are the results of your poll. So the answers are on your screen. Machine tool motors are AC3. Heating resistances are AC1, as I just mentioned in my previous slide. A cooling compressor is AC3. Ventilation motors AC3. Elevator motors AC3. Overhead crane motors is AC4. This is where I got it wrong as well. So if you have clicked it wrong, that's not an issue. Irrigation pump motors AC3. Mining conveyors is AC3 as well. Solar panels, there's a DC1, and power factor correction is AC6B. So hope you have got it right. So now I will talk about thermal overload relays. So we always come across thermal overload relays and trip classes. So this is something very important as well when you have an overload and you need to set the overload as per the depending on the application. So you need to take into consideration the tripping time as well, because every application or every might have a different kind of start. It can have a long start, and the motor can take time to actually go to its full speed. So depending on that, you need to select the right class. So for example, 10 trip class 10, the tripping time is from 4 to 10 seconds, 26 to 20 seconds, and trip class 30 is 9 to 30 seconds. Basically, it is a very heavy duty application. So here you can see if in particular, say for example, if the current is 7.2 times IE, that is a rated current, then these are the trip classes. For 10A or N class 10, it's basically you use it for a standard normal start type of application, compressors or pumps. Class 20 for fan coils, because they take time to reach its full speed. And for heavy duty, class 30, see if you can see the tripping time is from 9 seconds to 30 seconds. So now if you can see, so for the same 7.2 times the rated current, you have for different classes, you have different tripping times. So for class 10, it is around 7 seconds. For class 20, it is around it is around 15, and yeah, 30 it is again around 22 or something. So for different classes, you have different trip times. Now my last poll: which fault can an overload protect? Again, you have 30 seconds. Okay, this is my last poll. Try getting it right. You can see the results now. Okay, I'll go to my next slide. So the answer to it is over here. So overload can protect you when the load of the motor is too high and the motor is not running at full speed. It can protect if one phase is disconnected. It cannot protect if there is a short circuit in the motor winding. Okay, it cannot protect. So you need you need an upstream breaker to trip it, uh, or a manual motor starter basically. Um, if the starting time is too long, yes, it will trip. If there is high temperature in the cabinet, it can do, because the bimetallic streak basically will detect. It is a slow process, but it will detect. And the rotor of the motor is locked. Of course, it needs to do that. So I will go through some definitions of a manual motor startup. Okay, as for IC 60947-4. So a protected starter is an equipment consisting of a starter, a manually operated switching device, and a short circuit protective device rated at a unit by the manufacturer. And the manual motor starter are defined as combination starters. So a combination starter is an equipment consisting of a protected starter and an isolating function. So basically, it is a perfect solution for if it's a standalone a unit, then you can use a manual motor starter. So these are some of the definitions, or some of the diagrammatic representation, how you can actually represent a circuit breaker, a contactor, and overload. So number one, you can see over here, um, is a circuit breaker as per IC 60947. A contactor, you can see it's in two. 3 is an overload. 4 is a control switch, and it goes manual motor starter, which I'm covering over here, is 9. Where is it? It's here. Okay. So a manual motor starter can give you a complete, it's a standalone unit, and it can disconnect, it can give you motor protection, overload, and phase failure, and it can give you protection against short circuit as well. So it is a very good a solution. So how to select a manual motor starter? Very, very simple. You need to know the nominal current of the motor, and you need to know uh, what KA you want. So 100K, I mean, it is too high, I can understand, but the manual motor starter can actually has a short circuit breaking capacity of around 100K. But you need to make sure that if you see in the chart anything above 11 amperes or above a particular current, you need to use a fuse as well. So here's the chart. So if you can see, MS132 25 is only rated for 50K, and you need to have a fuse, and the chart gives you the rating of the fuse as well, and then you can get that 100K protection as well. Now, semiconductor switching. I'm just covering this only because we have electronic compact starters, and they have a particular definition as well in IC 60947-4-2. So a semiconductor switching device is a switching device designed to make or break the current in an electric circuit by means of a controlled conductivity of semiconductor. And an AC semiconductor motor controller, which is are our compact starters, is a semiconductor switching device that provides the starting function of an AC motor and an off state. So these are some of the diagrammatic representation, and if you can see, UC is the firing angle, which and it basically there are lots of different symbols over here, and it depends on the device. So a semiconductor motor controller is the one which we use in our compact starters. So this is a very compact solution what we have in the market. It is just 22.5 mm in width, high space saving in group mounting. It comes in direct and reverse starting. It has integrated overload as well. It can be group mounted. It comes in both ATEX certification, and also we have a variant for safety applications as well. You can get SIL 3 rating or PLE certification with Sentry relays. It is very easy to mount. I have wired this myself, and it's very easy to wire it as well. You don't need any additional circuits. It's just, I mean, everything is there, all the connections. You just have to pull some wires and just give it to your push button or an indication. Electrical facts. It is rated for motor application. It is 6.5 amperes, 400 volt AC. Resistive loads, it can go up till 9 amperes. Switching frequency is 2 hertz, 120 per minute, or 7,200 per hour. And the contacts in AC3, you can operate them 1200 per hour. I just missed this long electrical durability. 30 million electrical cycles, and the contacts go 10 million electrical cycles. So they do long last as well. So this is the difference. What I can show you over here. See, direct online. Contactor and an overload is replaced straight away by electron compact starter. Less wiring and less space needed, and just imagine the space saving what you can get with reverse starter. Two contactors and an overload and all the connections is replaced straight away by one compact starter. We can also do group mounting as well. If you can see, very compact solution if there are around few motors, and I'm sure you must have come across it if you're an electrical engineer or electrician. Few motors, and you need a contactor and overload. You can basically swap them to this the particular design as well. You can have a manual motor starter at the top that is only magnetic only for short circuit, and the branches you can have um, all these starters. So you can see around 6 starters downstream, and you can protect it by just one magnetic only manual motor starter. So AC1 category is basically you have contactors as well as you have electronic starter as well. So the only difference I'm highlighting over here is the contactor. You can see we are the duty or the utilization category is AC1, whereas for compact starter it is AC51, and similarly for AC3, for contactor it is AC3, whereas for compact starter it is AC53. We have lots of application, as I told you, they're all around us. Motors are all around us. You will find it in any buildings, for AHUs, for any controlling of a fan, in refrigerations, and all our products are there installed. I've finished with my presentation, and I am open for any questions.
Thank you, Francis. So now we're going to begin answering the questions that have been posted. As a reminder, you can still submit questions through the question panel in your attendee control. So we've got one question here asking, why is a series motor used in railway?
A series motor used in railways? I have no idea, to be frank, unless and until it is a DC motor. Yeah, I need to check that. I need to check the facts on it. So I will come back to you after this presentation.
Perfect. So we've just got one question there for now. If you guys got any more questions, please send them through. I'll give another a couple of seconds. But if not, I would like to say thank you, Francis. Oh wait, no, one more has come through.
Perfect. We can wait. We can wait for a while, I think.
So the question here is, like the different type category of contactor, is there a different type electronic controller?
Electronic controller in the sense, I need to, because we have a motor controllers as well, which with ABB we have UMC, motor controllers. So we have only one type, but they can do that particular unit can do different functions as well. But I will be presenting on it somewhere, I think, in August. Stay tuned.
Okay, another one's come in. Do you need to use a contactor when using a soft starter or VSD?
Yes. So if in some of the VSDs, they do have contactors inside. I mean, they have AF. If you go with ABB variable frequency drives, they have AF contactors in them. Whereas in soft starters, you might require it as line or bypass. So um, it depends. For bypass, you don't require an AC3, but for line, you might go. It depends on how you want it to use, especially with all the applications and all the requirements specifications. You have to go with either a line or a bypass, or with both.
Okay, and then another one is, what is the current rating maximum available for electronic contactor?
Electronic, you mean electronic starters? So for motors is 6.5 amperes, and for um, lighting loads or for resistive loads, it's 9 amperes.
Okay, and then with IE3 and IE4 with high inrush currents, can the manual motor starter magnetic trip handle the inrush without tripping, i.e. 9 times FLC inrush on DOL?
Yes, so I have come across this. So our manual motor starters are certified and tested for IE3 motors. For IE4, you might have to go because the inrush is really high. It might be more than 14 times, I think. So we have a special type of manual motor starter, which is for a transformer starting, and that basically can handle that kind of inrush. So it can handle 20 times the current. So yes, we have a solution for IE3 as well.
Okay, and
Sorry,
there is
IE4. Sorry, IE4.
another one's come through. Is the electronic starter follow type 2 coordination?
Yes, type 2, it can do type 2 coordination as well, but you need an upstream short circuit protection as well.
Okay, and then another one is why is starter is used?
A starter is used just to start and stop a motor, or yeah, it is very important to start a motor safely, because um, if you are not selecting the right components, then what might happen is there can be a really high stress on your system or your grid, and there can be a blackout. So instead of having that, if there's an issue in the motor, then the motor protection will take care of it instead of the main breaker being being tripped. What happens is the local system, which is the control panel and the short circuit device, it will trip. So starting is really important for a motor starter.
Okay, another one is does the electronic starter have a remote operation facility?
Oh yes. So I mean, there are terminals in the provided in the starter. You can just connect the wires to your push buttons, and you can switch on and off. So yes, you can do it.
Another one's come through. Which motor is used in traction system and why?
Which mode, which motors is used? I mean, that you need to ask is to a motor guy, basically. We the webinar is all about protecting a motor. It's not about motors.
Okay, great. Thanks. Oh no, one more has come through. Does the electronic starter have any communication options? Modbus, for example.
At the moment, no. But if you need something with communication, then we have a product called as UMC. It's a motor controller, and that's the one what we can use for your application.
Okay, great. I'll just give it one more second, Francis, just in case anything pops through.
Yeah.
Okay, perfect. Thank you, everyone. And that concludes our questions for our webinar today. Thank you, everyone, for attending, and we hope you found it useful. If there's any more questions that come through, we'll answer them after this webinar. You will receive a survey on the presentation shortly, and we would appreciate it if you give us your feedback. An email also will come out in approximately an hour with your certificate of attendance for this webinar. So we thank you for joining, and we hope you have a great rest of your day. So thank you, everyone. Thanks, Francis.
Thank you, everyone. Cheers. Bye-bye.